we're going to create a frequency table here. And if you can check this out, we have 50 numbers given. And we want to put those into an organized way to be able to use them. And that's where the frequency table comes in. So you can see all of the minutes, 1 through 9, are listed here. And then it's the frequency. So there's only one 1. But there are 3 2s. There's 1, and there's 1. So how many 3s are there? So you go through 1, 2, 3, 4, 5, and you count, and there are 6 3s. Well, if you look at this proportion of customers, we have 50 total. So we would take 6 divided by 50, which gives me 0.12, which is 12%. So go ahead and hit pause and fill in the rest of this using this data. All right, so I filled in the table, nice and neat. You can read it. You always want to double check, add these up and make sure they add up to 50, because if they don't, you made a mistake somewhere. So now we can use our frequency table to answer some questions. What is the mode value for the minutes customers waited? Well, mode means the most. I look up 12 is the biggest number, so the mode is 5 minutes because 12 people waited 5 minutes. What is the longest somebody from the study waited? Well, large number is 9 minutes. Does this mean nobody has ever waited longer than that? No. This is just for this study. These 50 people. This is not everybody. How many people from this data set waited at least 6? At least 6 means 6 or more. So 6 or more is after this. So I'm looking at these numbers here. So 8 plus 5 plus 4 plus 2 is 19 people waited at least 6 minutes. How many people from this data set didn't have to wait more than 3 minutes? Okay, think about this wording. They didn't have to wait more than 3. So how many minutes did they wait? 1, 2, or 3? Because if they didn't wait more than 3, they could have still waited 3. So we're looking for the people who waited 1, 2, or 3 minutes. So we add those together, 1 plus 3 plus 6, and that's a total of 10 people did not wait more than 3 minutes. What does the total of the frequencies represent? Well, that represents all people in this study. All people in this study. What's the total of the proportions? Well, 1, because proportions generally refer to the decimals. So what should the total of the percentages be? 100%. And in this case, we didn't have to round at all, so it came out nicely. Sometimes if you have to round your percentages, you sometimes might end up with like 99 or 101, depending on things. But we had nice numbers here, so it came out nicely. It generally should be really close to 100%. Well, it should be 100%. What proportion? Okay, now we're talking about proportion of customers waits 5 minutes. So we're looking at 5 minutes. The proportion would be 0.24. You also could have said 24%. If you were to select a customer at random, what's the probability of a 5-minute wait? Well, that's the same answer. Proportion or probability is the same thing, right? It's those P words. If you select one of the customers at random, what is the probability the customer waited 1 or 2? Well, we put these together. 0.02 plus 0.06 gives me 0.08 or 8%. Whether you talk about decimals, percent, it's the same idea. If you select a customer at random, what's probably the customer waited less than 10 minutes? Well, all of these are less than 10 minutes, so that would be 50 over 50, which is 1 or 100%. Because everybody in this study waited less than 10 minutes. What about more than 10 minutes? Well, nobody waited more than 10 minutes, so the answer is just 0. Can't happen because nobody did it. What's the probability the customer waited at least 7? That's 7 or more. So I'm looking at 7 or more, and we're looking at probability. So I'm going to look at 10%. I'm going to do percents, plus 8%, plus 4%. So if I put those together, I get 22% is the probability that somebody waited at least 7 minutes. And now we're going to do a histogram. Now notice that these are decimals, so we are dealing with the proportions on that side. Okay, so I'm going to hit pause and fill them in, so you should do the same thing. See if you can do yours with the proportions. All right, so that's not beautiful, but it kind of, I mean, you get the idea. It's a little bit harder to do that with a stylus and not with, a pencil and piece of paper. But first thing it says, label the horizontal axis. Well, this is minutes weighted. So you always want to make sure you're labeling your axis. You always want to make sure you have a title. They give us a title, so that's good. Is the time customers wait for service at a fast food restaurant symmetrical or skewed? Well, this is my tallest bar, and you can see how it kind of goes nicely in both directions. I would call this symmetrical. Now, number 15, if the graph had percentages on the y-axis, would it look the same or would it be different? So right now they're proportions. If this would have been percents instead, it would be the same. And I say it would be the same because think about it. We would still have, instead of having 0.02, we'd have 2%. Instead of 0.06, we had 6%. So they're still going to look the same. They would just be percentages instead of decimals, but the shape and everything else would still be the same.